This is section 1.1 and 1.2 combined. This is continuing review. We're going to look at solving equations when there's one unknown or if there's two or more unknowns. Reading the question, and I'm serious about that, it's a major part of this course, and the smokestack problem. Okay, first we're going to look at solving a basic linear equation. The first step is to get rid of the parentheses, and we'll do this by distributing. So the left side stays unchanged. On the right side we have negative 36x minus 20. Now that all the parentheses are removed, we want x's on one side and non-x's on the other side. So I'll move my x's to the left-hand side. I'll do that by adding 36x. That'll cancel it out on the left and on the right, and I have 39x on the right. And then I need the numbers moved over to the other side, so I need to cancel out this negative 8, and I can do that by adding 8, and I have negative 12. Now I have 39x equals negative 12. I need to get rid of the 39. It is attached to the x with multiplication, so to get rid of it, I divide. X is negative 12 39ths. There is a common factor of 3 in there, so I'll divide by 3, which makes negative 4 over 13. That's a basic linear equation to solve. I think most people will remember how you do that. Question number 1 in this section is a basic linear equation. The only difference is that instead of having a nice integer number like 3, we've got 3.25. Instead of having take away 8, we have take away 8.633. You're going to do the same process. You're going to have to keep track of these decimal places. So the first step will be to distribute this through negative 3.6 times 8.625 and keep all the decimal places. You don't round until your final answer, so keep all of your decimal places, write it down on a piece of paper, and then when you're all the way done, you will round to 3 decimal places. The next kind of solving we're going to talk about is solving for a variable. Right now I've got an equation and it's not solved for anything. I've got two variables, x and y, and if an equation is solved for a variable, you've got x by itself, but it's slightly more than that. You can't have any x's anywhere else. And the same thing, if it's solved for y, you'd have to have y equals, and then what you've got on the other side can't have any y's in it. Just to clarify, if this were my equation, is it solved for t? Well, t is by itself, but it is not solved for t because there are t's somewhere else in the formula. And if it's solved for t, you can only have that variable by itself, and it can't be anywhere else. First, I'm going to solve for x. First step would be to identify where the x's are. It's only in one place, so I need to get rid of the 6 and the 8y. I'll get rid of the 8y first by subtracting 8y from both sides. Then I have 6x will equal 3y minus 8y, negative 5y plus 10. And now I need to get rid of the 6 by dividing. You can divide the whole side, or you could divide each term separately. It's up to you. WebAssign will take it both. X is negative 5y plus 10 over 6. Okay, same equation, but this time we're going to solve for y. When you solve for y, you want to have y equals, so the y has to be by itself, but then on the other side, you can't have any other y variables over here. The first step is to get all of the y's on the same side. So if I look, I've got a y and a y. So I've got y in two places, and to get them on the same side, I'll move them all over here to the left. So I'll subtract 3y, subtract 3y. 5y plus 6x will be 10. Okay, now I've only got y in one place in the equation. To get it by itself, I need to get rid of the 5 and get rid of the 6x. The 6x is connected with addition, so I will subtract 6x to get rid of that. 5y is 10, take away 6x, and then to get rid of the 5, I divide. Y equals 10 minus 6x over 5. Okay, going to WebAssign, you have two problems. Solve for y in terms of x. That means you want y by itself and x is on the other side. So here we have, this would be y in terms of x. It means y is by itself on one side and the other side only has x's in it. And the first one that we did, this is x in terms of y. X is isolated, and the other side of the equation only has numbers and y. So question 2, you're going to solve for y, and then question 3, you're going to solve for t. Question number 4. Okay, high interest rates make it difficult for people to pay off a credit card debt in a reasonable period of time. Very true. The interest, capital I, in dollars, paid on a $10,000 debt over 3 years when the interest rate is R% can be approximated by the equation shown. All right. In reading the equation, look at the formula that you're given, and I have two variables, capital I and lowercase r. Make sure that you understand what each one means. I is the interest that you earn, and that's in dollars. R is an interest rate, and that's a percent. And the formula, this formula that they came up with the 175.39, this formula is only good for a $10,000 debt over 3 years. If the credit card interest rate is 15.6%, find the amount of interest. Okay, so first, when you read that, credit card interest rate is 15.6%. That would be the R. Find the amount of interest paid. That would be finding I. Careful. Whoever set up this equation they have the right to set it up how they want. And what they set up was that it's R and then percent. So when they say 15.6%, this is R and then percent. So when you plug in a value for R, you're plugging in 15.6, not 0.156. Could that decimal also be 15.6%? Yes. Well, then how do I know when to use the decimal and when to use the percent? The problem has to tell me, and they said the interest rate is R%. R% means R is 15.6. So I have I over 175.393, 0.663 equals R. Okay, now just notice how different this would be to solve if I put in R in the wrong format. Having this equation equal 0.156 is very different than having it equal 15.6. So when I say it's important to read the question, I mean it. To solve for I have to get rid of the 175 and the 0.663. Subtract 0.663 from both sides, 14.937. And now to cancel the 175 is dividing the I, so to cancel that out, we'll times it. And when I'm multiplying, I create factors, so those will cancel out. Then over here, I have to also multiply by 175.393. And I got 2619.845241. So you keep all of the decimal places while you work through the problem, and then it says find the amount of interest. It's in dollars, so we usually go to the nearest penny. So nearest penny would be right there. I use the next decimal place to decide how to round the previous one, and I have 2619.85. So here's where we're at. We talked about solving equations with one unknown, and you get a value for your answer, a number. If there are two or more unknowns, you get a formula for your answer, like y is 10 plus 6x over 3, that kind of solving. And then reading the question, that R% is a big deal. That's going to come up from time to time throughout the course. And whether you're talking about average cost, those kinds of things. Last, we need to talk about the smokestack. Suppose that the cost, C, in dollars, I would start to write this out. C is the cost. It's measured in dollars, and it's of removing P% of a particulate pollution. So P is a percent. Okay, so if you remove 99%, then P would be 99, because it says we're measuring it in percent, not in decimals. And then they give you a formula that interrelates those two. So cost is 7600 P, 100 minus P. Find the domain of the function in interval notation. You've probably heard the word domain before. You should have some emotional scars related to that word. But domain means all of the valid inputs. The input value for this equation is P. So cost is a function of P. Give me a percent and I can tell you the cost. And I want to know what values can P have, which ones make sense in this problem. I do need to say that when in WebAssign in business applications, sometimes it's a little bit vague. There's a mathematical domain, and then there's an application domain. So the math is, all the math cares about is you can't divide by 0. So 100 minus p can't turn out to be 0, so p cannot turn out to be 100. That's all the math cares about. But then there's a common sense application, or in the context of the problem, p can't be 120 either. Now there's no mathematical reason why p can't be 120, but it's just in this problem. Can you remove 120% of the pollutants in a smokestack? No. So that doesn't work. In fact, anything over 100 is out. So p has to stay less than 100. And I can't have p be negative 20 either, because I can't take away negative 20% of the pollutants. So in the context of the problem, the percent of pollutants I can remove has to stay less than 100. It can't equal 100 for mathematical reasons. And it has to stay greater than 0, but I could remove 0% by just doing nothing. So my domain is from 0, is the least I could do, up to as close to 100 as you can get, but I can't actually have 100. How do you put that in interval notation? This is a Math 1010 pop quiz. Left endpoint 0, right endpoint 100, and you separate them with a comma. If you can include the endpoint, you put a bracket, a straight brace. If you cannot include it, if it's strictly less than, then you put a parenthesis. And in WebAssign, you just type 0, and as soon as I type that square bracket, it's going to assume a square bracket on the other side also. So 0, comma, and up to 100, but at 100 I can't have the bracket, so I need to change that to a parenthesis. That's the hardest part of this problem. Now find the functional value c of 46. We just put 46 in for p over 100 minus 46 and work that out to see what you get, rounding to the nearest penny. So I got 6,474, and then to round to the nearest penny, there's my pennies. The next number after it is less than 5, so I wouldn't round up. I just keep it at 6474. And then the question is, 6,474 what? Well, this 46 is a p. How do I know it's a p? Because it's a function of the variable p. So p equals 46. Then the output is this variable. This must be a capital C. 647407. So when p is 46, that's percent of pollutants removed. It cost me $6,470 to get it done. And then you can go down through the rest of the problem and find that if you're trying to remove 90% of the pollutants, you could expect it to cost more. 99% of the pollutants, 99.6% of the pollutants. And again, it is impossible to remove 100% of the pollutants because, well, you probably just can't. Like practically you could not get all of the pollutants out. But the equation doesn't allow it either because you would end up dividing by 0. Okay, you have other homework, other helps and tips in the Canvas videos, and you have the watch-its, and I'll see you in class.